Okay, second practice problem for the day says the label has come off a gas cylinder in your lab. To identify the gas, you evacuate a 5-liter flask, seal and weigh it, and let gas flow into the tank until the gauge pressure is 1 atmosphere. This should be gas flowing into the flask as well, just for clarification. The flask is reweighed. The added mass is 13 grams. If the room is at normal conditions, what is the gas? So already you know you got pressure, volume. It's going to be a PV equals nRT. The room being at normal conditions, what does that mean? So room temperature is usually taken as 25 C or 298 K. Normal conditions would also be P is equal to 1 atmosphere or 101,325 pascals. Okay, so this is another one where I have an initial state and a final state. So initial state of the flask, that was a horrible drawn flask. Okay, I had to pause and take my time with that drawing. So once again, I have a 5-liter flask. If I assume that's made out of glass or something else rigid, I know the volume is not going to change. So volume is equal to 5 liters. My pressure initially, P1 is 1 atmosphere. P2 is going to be the gauge pressure is 1 atmosphere. Once again, that means you have to add back in atmospheric pressure. So this is 2 atmospheres. This is going to be the absolute pressure of the full flask. My temperature is not going to change, so T is going to be the same in either case. So that was 298 K. All right, so for the full case, I have PV and T, and therefore I can calculate N. For full flask, N is equal to PV over RT. And I'm going to do this one in SI units. So P is 2 times 101,325, 2 atmospheres times 101,325 pascals per atmosphere, times 5 liters. And if I want this in SI units, I'm going to convert to meters cubed, times 1,000 liters per 1 meter cubed, over R, 8.314, times T, 298 K. Okay, so I can solve for the number of moles here. And this calculation gets me about 0.409 moles. So this is the amount of moles that I've added to the flask. Now, how would I get from the amount of moles added to the flask to an identification of the gas? Well, if I look back at the problem statement, I know that the added mass is 13 grams. So the fact that I'm adding 13 grams of mass while at the same time adding 0.409 moles means that I can calculate what that molar mass must have been. So if I add 13 grams and at the same time I add 0.409 moles, I know that 13 grams per 0.409 moles means that the molecular weight of the gas must have been 31.78. 31.78 grams per mole. So what gases do I know that have a molecular weight of close to this? And if you remember, oxygen would be an example. O2 has the same molecular weight, has a molecular weight of 32 grams per mole. Now, of course, other gases could have the same molecular weight, but this would be a way that you could identify what it could possibly be. So I would say that O2 is a strong candidate, unless there is another candidate for gases that you would know of that is 32 grams per mole. So that'll be it for this video, and that'll be it for this class, short class period today.